If you want to have the best understanding of reality, you need to explore its boundaries. Scientists have already achieved feats that blur the lines of reality, like using the quantum explorer to unlock secrets. No, it's not a theory. It's not a Hollywood script. It's real. In a laboratory at Harvard University, light, the fastest thing in the universe, the very measure by which time and space are defined, was slowed down, not just slightly, but drastically. From a blistering 6,000 miles per second to a crawl of just 38 miles per hour. That's not a typo. The very essence of how we perceive time and reality was stretched, paused, and released, like pressing play on a moment suspended in space. To understand how extraordinary this is, you first need to grasp what light really is. Light is not just illumination, it's information. It's the means by which we see, by which we measure, and by which we understand time. When you see a star twinkle, you're seeing light that has traveled years, sometimes millions of years, to reach your eyes. You're literally looking into the past. Light is the ultimate cosmic messenger, and in our reality, it's always moved at one fixed constant speed in a vacuum, 299,792,458 meters per second. This speed is foundational to Einstein's theory of relativity and the laws of physics themselves. It's the cosmic speed limit, or so we thought. Enter Dr. Lena Howe and her team at Harvard. Using a cloud of sodium atoms chilled to just a few billionths of a degree above absolute zero, they created something both ethereal and extraordinary, a Bose-Einstein Condensate. At this temperature, individual atoms lose their identity and merge into a single quantum entity. Essentially, a new state of matter where quantum effects that are normally invisible suddenly become large and observable. Think of it like a microscopic dance where trillions of atoms move in perfect synchronicity, becoming one. This ghost-like state of matter behaves like a quantum canvas. When the team fired a laser beam into it, the atoms responded in a way that would shake the foundations of physics. Instead of letting the light beam pass through at full speed, the atoms interacted with it via a process called electromagnetically induced transparency, EIT. This bizarre and beautiful quantum trick allows light to be slowed, trapped, and later released, without losing the data it carries. In essence, they pressed pause on a beam of light. They halted time, held it, and then hit play again. Imagine what this really means. By stopping light, we are halting the very flow of time-bound information. The photons, carriers of energy, memory, and moment, are frozen, their journey interrupted. And when they're released, they continue on as if nothing happened. This isn't just a delay in perception, it's a delay in reality. You're not just watching a moment, you're holding it in your hands. Now think about the possibilities. In quantum computing, light could be used not just for processing, but for storing information. Forget about memory chips. Imagine storing data in frozen light, only to be reactivated when needed. In quantum communication, such control over light could create perfectly secure transmission channels, where intercepted data disappears instantly. And in future internet systems, optical light routers built on these principles could move data at previously unimaginable speeds, with almost no energy loss. But it goes deeper than technology. The philosophical and scientific implications of this are staggering. If we can slow light and thereby delay perception, are we starting to manipulate the perception of time itself? Could we eventually build systems that loop moments, replaying events by re-releasing the trapped light that captured them? Could time be bent, buffered, or controlled through the same quantum laws that allowed this experiment to exist? Because if you slow down the messenger, light, then you're not just affecting visibility. You're affecting the delivery of reality. This is no longer just about optics, it's about time warping, about dipping our toes into a new dimension of physics, one where information is no longer bound by the arrow of time. We're not talking about DeLoreans or time portals yet, but we are talking about the fundamental framework of reality becoming something we can touch, pause, and shape. It also begs a deeper question. What else don't we know? What else has been hidden, erased, or purposely left unexplored? If light, the most trusted constant in the universe, can be paused, what else about our universe, our history, and our existence is more flexible than we've been told? That's exactly the kind of question we live for at A Third Eye. We're not just observers of scientific wonders, we're explorers of the unseen, the cosmic, and the suppressed. At A Third Eye, we uncover the buried knowledge of ancient civilizations, the hidden patterns in physics, and the truth behind humanity's forgotten past. We connect scientific breakthroughs like this one to bigger cosmic narratives that stretch far beyond the lab and deep into the soul of reality itself. If you feel like there's more to life than what we're shown, if you believe there are truths yet to be told, if your mind seeks, questions, and refuses to be boxed in, then you are one of us. Join the movement. Follow a third eye for more discoveries that mainstream science tiptoes around. From light speed manipulation to ancient knowledge systems, from cosmic code to lost human history. Like, share, and awaken someone else's curiosity. Let's open minds together. The universe is waiting, and it's time we start looking with our third eye open.